I have a second channel, Cube Compium TTX.
Hey everybody, so I just got done cracking open another Toshiba laptop battery pack, just like the previous one I did the other day. It contains these Panasonic CGR 18650CG 2250 milliamp hour cells. This pack was dated 2011. I'm not sure what the last pack was dated, probably a similar time. So if you didn't watch the previous video, the test video in particular, you'll see where two of the cells out of the pack were more or less DOA. They were holding below 2 volts, and typically when they hold below 2 volts like that, particularly when the rest of the cells are holding a significantly higher voltage, I usually reject them right away. And the remaining 4 cells were holding around 3.5 volts. It all seemed good at first, but once I started charging them up, once they got above 4 volts, they started getting hot. Which by that point they were just sucking energy from the charger and expelling it as heat, not really charging up the batteries or the cells. So those cells, although I still have them, they're going to be getting recycled anyway. When you have cells that get hot in the charge cycle, just don't bother with them. It's not worth the risk, because that usually tells you that there is something going wrong with the cell. So this pack here, same model, but we'll see if these cells fare any better. I literally just got done cracking the pack open, and I just desoldered the circuit board. It was pretty much the same as last time, maybe a little easier. This one actually come open a little easier than the previous one. I was gonna get video of it, but the camera battery quit just like a minute in, and my camera, of course, likes to actually not shut off when the battery goes dead. It just quits recording. It makes you, and you're sitting there thinking you're actually shooting video when you're just talking to yourself. So that's great. So alright, anyways, enough of the talking. Let's go ahead and get into it. So we're going to start out by testing the series voltage of the entire pack. We're getting 8.55 volts. Alright, so the first bank of cells, we're getting 3.78. Second bank, 3.57. So it's likely these here are going to be bad. I'm getting absolute 0. So I'm not sure if, well, I would think that the CID hasn't popped on these, because I do get voltage through them. Hang on a sec. Oh, I see what was going on. Okay, so these here are only getting 1.19, so 1.2 volts. So these two are bad. The remaining 4, we'll have to see. They're holding a good voltage, but we'll have to see if they get hot when charging. So I'll go and separate these, and we'll go from there. Here they are right here. These are Panasonic CGR 18650 CGs. These are, I believe, 2250 milliamp hour cells. That's what they're rated for, at least. So we'll go ahead and try them out today. So I'm going to go ahead and peel off these discs on the top. Just make sure that the cell wrap is okay. Just go ahead and peel them off because they will eventually end up coming off anyway. Now that they're outside of a laptop battery getting used as individual cells. Okay, so I'll go ahead and insert these in numerical order. I have a number set where I can keep track of which one is which. First thing I'll do is see what the voltage is. So they've been sitting for about a day now. .78 and 3.57. I'm going to do a quick test. Just see what the internal resistance is in milliohms. This one here is a little high, but the thing with this charger is sometimes if you don't have the connection absolutely perfect, it will give you false readings that are higher. So it looks like they are actually close to 200 milliohms, which is kind of high. However, it's not a deal breaker exactly. They will still be usable, but anything that draws a bit more current, you'll won't get as much. Typically, won't get as much capacity from them. So, what we're going to do is we're going to go ahead and charge these up to full charge, 4.2, and see if they get hot. If they don't get hot, we'll then discharge them and see what we can pull out of them as far as capacity goes. Charge them at 1 amp. Okay, so now they're charging, and what I'll do is I'll provide an update as soon as anything new happens. Okay, everybody, so like the last cells, we've got heaters, all 4 of them. What's interesting is these things, they pretty quickly came up to 4.1 volts. The charger had actually went into constant voltage mode and started slowing the current down. It was down to about, I'd say, 500 milliamps on the first 2, but now the current has actually gone back up. Once I get to it, yep. The current on cells 1 and 2 has increased to 800 milliamps. You can see it's kind of fluctuating around a little bit. Let's get a temperature check. Cell 4 is at 46 Celsius. Cell 3 is at 46 degrees Celsius. Cell 2 is at 47. And cell 1 is at 48. So it didn't take long for them to start getting hot. I mean, they were doing fine at first. They were cool, and then all of a sudden, I don't know, about 5 minutes later, I come back in here and they're getting hot. So not too good. That one's getting noticeably warmer. Yeah, we're getting close to 49 degrees Celsius now. And climbing. So I'm going to go ahead and stop the charge on these and let these cool off. And then once they cool down some, I will go ahead and discharge them. So yeah, that's unfortunate, I'll tell you. Harvesting laptop batteries, it's really a gamble. You'll get some good sales and you'll get some bad sales. It seems here lately I've gotten a lot of bad sales. Yeah, because these, I mean, just all of a sudden, just out of nowhere, start getting hot. So, yep, these will definitely be getting disposed of. They'll be getting recycled. So, once they cool down, I'll put them back on the charger and discharge them, see what we get out of them. Okay, everybody, so the discharge has finished, but by looking at these numbers, you would probably think otherwise. That's how much these cells bounced back after the charger stopped discharging them. This thing stops charging, I want to say 2.9 volts, something like that. And these things, they really bounced way back. And they've mostly cooled off by now. I let them cool off some and then put them back onto the charger and start the discharge cycle. And of course, the fan in this thing helped drew some air through here, and it cooled the cells down. That have a look at this. Yeah, guys. The highest we got was 178 milliamp hours. Yeah, these cells are junk. They're done. Here's the amount of time it took to discharge them. Yeah, look at this. Between 6 minutes to 11 minutes. That didn't take long. As mentioned, laptop cell harvesting, it's really a gamble. Sometimes you'll get good ones. Other times you'll get bad ones. So I guess I might continue on further with this. I might crack open another pack and see what I have. I'm gonna probably move on to a different brand this time. I got some packs over there that have I believe LG Chem cells in them, maybe some Samsung, I don't know. I'll be cracking open either another Toshiba pack or an HP pack. So stay tuned for that. So anyways, hope y'all enjoyed this video. Thanks for watching. Well, everybody, that's it for this video, but don't forget there's a lot more interesting stuff on the channel to check out. Also, if this is your first time visiting this channel, feel free to subscribe to Cube Computer channel, and also don't forget to tick the bell so that way you'll get notified of new video posts. If you like this video, please give it a thumbs up, but if you really didn't like it, there is the alternative option available as well. Also, feel free to check out my second channel, CubeComp MTDX. There you'll find videos about bicycling, weather, elevator tours, and all sorts of other neat, interesting stuff. I hope you guys enjoyed this video. Feel free to come back, and thank you for your support.